Oh, dear professor, I would like to submit homework 5. Could you please explain the operating principle of open loop control and closed loop control, and provide clear example to illustrate the difference between figure 1 and 2. First one, an open loop PID. Open loop PID can only be applied to genetic relatively simple linear control without a feedback mechanism. It lacks corrective capability, deserved output response, manual input deserved target, setting the motor speed to 300 revolution per meter. Controller. It calculates the control output based on the input target value without error correction logic. It only outputs a fixed control signal according to the set value and cannot read the actual operating state of the equipment. Um, act out and accept the controller's electronic signal to produce physical action. Process the physical equipment and physical process to be controlled. Output in an open loop configuration, this signal is not retained back to the further end. So the controller has no access to the actual output value whatsoever. Second, closed loop PID refers in input the desired value that you want the system to reach, such as a target motor speed of 300 RPM or a temperature control set point of 25. Error detector, error detector, error signal for PID conclusion. The amplifier is essentially the PID controller. It performs proportional, integral, and derivative conclusion on the error signal, amplifies and corrects the error and output or control signal. Act outer receive PID output signal and exerts physical mission, motors, PW, drivers, etc. Plant controller plant motor heating furnace, robotics, manipulators, mobile volcano, etc. Output actual state of the controller plant correct rotation speed, temperature, and position. Sensor, it samples the actual system output in real time, can converts it into an electric signal and feed it back to the error detector to form a feedback loop. This is the fundamental difference between closed loop and open loop. Okay, next, let's move it on the code ourselves. Implementing the PID formula in C code requires several segments. Conclude the error value. Conclude the error value. Compose the definitive. Integrate anti-window limits. PID output conclusion. List below are the PID parameters together with the maximum value for integrating magnitude and error magnitude. Okay, let's demonstrate how PID operates. First, the proportion KP. The proportion parameter that determine the system responses and response speed. The integrate KI integrate parameter and occurs error over time, enable the system to reach the target value rapidly. The derivative KD parameter surpasses overshot for correction. Generally speaking, when set a genetically large p-value and moderate d-value and a tiny I-value, okay, we can see Kp okay. Ki error over time. KD parameter suppose overshot, overshot, overshot. This target overshot. We set KD. Okay, that's all.